Okay, guys, we're going to do check your understanding on page 378. A large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X be the number of cars sold and Y be the number of cars leased during that first hour of business on a randomly selected Friday. Based on previous records, we have our probability distribution models. We got our mean and our standard deviation of the cars sold and the cars leased. Okay, in the previous check your understanding, we figured out a total. We added them up. Now we're going to find a difference. We're going to actually subtract X and Y. Okay. So again, X and Y have to be independent, and that's really important. You need to have that in order to be able to calculate standard deviation, and we'll understand that coming up. Okay, so the first thing I'm going to do is the mean of the difference. Okay, well the difference is X minus Y, so it's pretty straightforward. The mean of X minus the mean of Y. So X is cars and Y is cars. X is cars sold, Y is cars leased, so the difference is 0.4. Okay, so again, if I was going to interpret that on many Fridays, the dealer, okay, we have to interpret this a little different because now it's the difference. On many Fridays, the dealer typically sells 0.4 cars more than it leases. Okay, or I could say typically sells about. Let me put in the word about. Okay, because that's what that means. That's the difference between the cars sold and the cars leased. Okay, so again, mean is pretty straightforward. Number 2 says to compute the standard deviation of D. Okay, and again, you would think standard deviation of D would be standard deviation X minus Y, standard deviation of X minus standard deviation of Y. But when you work with standard deviation and you're calculating it and you're combining it, because again, this is just another combo, you've got to work with variance, okay? So if I square this, I will square this, and then suddenly when I square each one of these, this becomes a positive, because as soon as you square that number, it's going to become positive, okay? So even when I'm dealing with a difference in standard deviations and combining standard deviations, I'm still going to add. And funny thing is, that's exactly the standard deviation when we added X and Y. So this is the exact same thing from the previous check your understanding. So I would take 0.943 and square it, 0.64 square it, I forget what I got, 1.2988849. Take the square root in order to get the standard deviation. So again, it would be 1.14 cars. And that is the exact same thing, as the check your understanding on page 376. Okay, because no matter whether you're adding or subtracting, standard deviation always adds. Okay? All right, let's do the transform, then combine, just like we did before, okay? But this time, we've got to do it by subtracting. So I'm still going to get $500 per car sold and $300 per lease. Let me move this up because this is like wiggly. Okay. So again, the mean of the difference is simply going to be, Okay, the bonus of the difference. So the mean of the bonus is simply going to be the mean of the bonus of X minus the mean of the bonus of Y. So again, I'm going to do 500 times 1.1 minus 300 times 0.7. I got the wrong one. So throw that in the calculator, and I get $340. Okay, so that's the typical difference of bonus I'm going to get between the cars and the leases. Okay, or between the selling the cars and selling the lease and leasing the car. Sorry. Standard deviation of the bonus. Again, you would think it would be the standard deviation of the bonus of X minus the standard deviation of the bonus of Y. Okay, but again, you've got to deal with the variance. Okay, so let's transform first. So if I'm going to transform, standard deviation of X, it's just 500 times 0.943. Standard deviation of the y is our least cars. Okay. But in order to, I'm sorry, once you square everything, it becomes positive, of course. Once I put those in there, I've got to square these. So I'm basically squaring both pieces. Okay, and then I add them. Okay, now in order to get the standard deviation of just the bonus, I do have to take the square root. Okay, so funny thing is that is the exact standard deviation from the previous check your understanding on page 376. Here, come over here. Show this. Okay, this is what we did on check your understanding page 376. I just did a little bit differently as far as what it looks, but the math is still the same. Okay, so the good thing about standard deviation is it's always addition. Okay, whether you're just doing a combination, addition or subtraction, standard deviation is always adding the variances. And if we're doing a transformation and then a combination, do your transformation first and then square everything to turn them into variances, and it just becomes addition, even though originally we were doing a subtraction. Okay? I think that's it. All right, see you next time.